Okay, Assalamu alaikum. Can you hear me?
Yes.
So, tomorrow you have exam and the questions will comprise from the Oswald process, yeah?
Yeah.
And we have completed everything about equilibrium constant and other stuff, so we
Yeah.
don't need to focus on that. Now here in depth study you will have questions from Haber process, right? So here what you should know is we have some industrial processes, right? So did you study about the industrial chemistry anywhere?
No, we were meant to learn it ourselves.
Okay. So here uh, you see you might have heard about this industrial revolution.
Yeah.
Okay, so after the industrial revolution, we don't need to know about the historical background. So if you have taken history as a subject, you would have studied that. But now, after the industrial revolution, we were forced to manufacture many chemicals using, in large quantities, right? So for that, the laboratory setting will not be useful. So industrially, we have to manufacture chemicals using some processes, right? So we have named some processes. For example, if you want to synthesis or produce ammonia, we will call it as Haber-Bosch process, right? Process. Now this is what we have to study for this what do you call this depth study. And now we have to study about Ostwald process, right? What is that? Ostwald process. So using Ostwald process, what do you manufacture?
You manufacture HNO3.
Okay, HNO3, nitric acid, right? And we have contact process, right? So these are famous industrial processes. Contact process. Do you have any idea about contact process? What do we manufacture using contact process?
Is that the same one as the Haber process?
Yeah, yeah, not same process, but
So,
for manufacturing sulfuric acid, right? H2SO4, like we use Haber-Bosch process for manufacturing ammonia and Ostwald process for manufacturing HNO3 for producing H2SO4. H2SO4 is also a useful chemical, right? So this is an acid and this is also an acid. So we are directly using all these acids in the laboratory, but they should have already produced, right? So industrially this is how we produce, right? So these are just the names of the procedures that we are going to use, but we have to study all these processes in details, right? So do you have any, okay, so I already explained about this uh, Haber-Bosch process in the video that I sent you. Now, do you have any specific doubts or anything to discuss further regarding this HNO3 production? I'm sorry, NH3
not
production.
really.
Ah, right.
Hello?
Yeah.
No, I don't have any questions.
Okay. Okay. So now we will go to this Oswald process, right? So I have just okay. So you should know the background of this Haber-Bosch process, right? So since we are studying equilibrium, this is the okay. Let me erase all this, right?
Yeah.
Right. So since we are studying this related to equilibrium, we should only focus on the equilibrium reaction, right? So in the production of ammonia, the raw materials are nitrogen gas and hydrogen gas, right? So now how do you obtain this nitrogen gas?
Uh, uh,
What is the
it's
source
present in the
of nitrogen
right?
gas? Yeah, what is the source of nitrogen gas?
Isn't it just present in the atmosphere?
Yeah, atmosphere, right? So what we will do is in the atmosphere we have 78% of ammonia, I'm sorry, this nitrogen gas, right? So first we will compress this air and make it into liquid, right? So liquid air. Now if you have liquid, now we have N2 gas liquid, O2 gas liquid, and other gases liquid, but here in large proportions we have nitrogen gas and oxygen gas only, right? So this is around 78 and this is around 21%. Now if you have a liquid and if you want to extract or separate the compositions, what method you will use?
To separate what, sorry? N2 and O2.
Separation method. What is the separation method that we can use to separate liquid mixtures?
You could fractional distillate.
Yes, very good. Fractional distillation, right? Now using fractional distillation we will separate this nitrogen gas and oxygen gas, but we are not interested in this oxygen gas. For the production of ammonia we need N2, right? So this is how N2 is obtained, and hydrogen gas can be obtained by cracking hydrocarbons, right? So for example, naphtha, there is a hydrocarbon from carbon 6 to it can take a carbon 13, right? So this is a long chain hydrocarbon. By cracking it you can obtain H2 gas, right? So this is industrially done. Now you see here you have to know some basic backgrounds also. Here this ammonia is mainly used in the production of fertilizer, right? Fertilizer. So what is the major usage of ammonia? This might be asked in the question, right? And when you are writing your report you can just insert or include this information also, right? So majorly ammonia is produced for producing fertilizer, especially urea, right? Urea. Why? Because they have given a basic idea. Just read this one. In modern context, manufacture of ammonia is mainly needed for the production of artificial fertilizers, right? So naturally also in the soil we have natural fertilizers, but in order to improve the growth of plants we have to artificially also manufacture fertilizer and incorporate to plants. Okay, now you can see at present the world population is nearly 7.3 billion, right? So sometimes now it may be around 8.4 or something like that, right? Now just to have an idea, now let's say this is 7.3 billion and by 2050 it will become 9 billion. Definitely the population will grow, right? Exponentially grow. So for the increase in the population we have to provide food to all human beings, right? So for the production of food we rely on animals and plants majorly for food, right? So animals and plants. So in order to enhance the growth of plants, and directly animals also rely on plants, right? For all these things we have to grow more plants, right? For growing plants what do we need? We need fertilizer. In order to produce fertilizer we have to manufacture ammonia, right? This is the idea. So production of fertilizer is considered as an important field of chemical manufacture in this regard, right? So did you get an idea of why we have to produce ammonia?
Yeah.
Okay, why? Because for the production of fertilizer, right? So here you see with the increasing of the population, production of food is necessity. Right? Right. Now you can see of the total ammonia production, right? So among all the ammonia, now we have to allocate the produced ammonia for different purposes, right? But 83% of produced ammonia is used for fertilizer, and among them 80% majority of the ammonia is used for the production of urea, right? So urea, have you seen those are kind of white color granules? Urea.
Sorry?
Have you seen urea?
No.
Okay. So urea, urea is a fertilizer.
Yeah.
Okay, that's fine. Now, here of the total ammonia production, okay, that is okay, right? Now the equation that we have to know is this one. That is very simple, right?
Yeah.
Right. So nitrogen gas and hydrogen gas. So sometimes they might ask, what are the raw materials used in the production of ammonia? What's the answer?
Nitrogen gas and hydrogen gas.
Nitrogen gas and hydrogen gas. And here you can
The
see,
Haber process, right?
yeah, during the Haber process. Now during the reaction, ammonia gas is produced along with heat. So here we should know delta H is negative. So this is an exothermic reaction. This is an exothermic reaction. Now industrially, if you want to produce ammonia, we should reduce costs. What are our objective? We have to use less cost, and the efficiency of the method should be high, and our yield should be high, right? So with you know, what do you call, with low investment we have to get more benefits or more revenue. This is the purpose of any business or industrial processes, right? So now we have to reduce the cost. Now this is the idea: reduce the cost but increase the efficiency. Increase the efficiency means
increase the speed of it.
increasing the speed of the
and
reaction,
the
right? Okay. And we have to get more revenue. Get more revenue, right? So if you want to get more revenue, we have to increase the yield. We have to increase the yield, right? Now for these predictions we can use two methods, right? So the first one is Le-Chatelier principle, and the other one is the equation that we have studied, delta G is equal to delta H minus T into delta S, right? So using these two chemical principles, we are going to analyze what we have to do in the industrial processes, right? Now you see here, this is a exothermic reaction. This is an exothermic reaction. Now naturally, for this reaction to happen, we have to overcome a specific activation energy. For that, what we have to do, we have to provide energy to the reactants. We have to provide energy to the reactants. So how can we provide energy?
You can increase heat.
Yeah, you can just increase heat, right? But now you see here, practically if you think, if you increase the heat of the reaction, what will happen to the yield according to Le-Chatelier principle?
It will decrease because there are more because it's a exothermic process.
So the yield will reduce. The yield will reduce. So we can specifically use 450 degrees Celsius in order to overcome the activation energy. In order to overcome the activation energy. And we have to apply some pressure also. We have to apply some pressure also. Why do we apply pressure? Now if you apply pressure, the volume will reduce, and the collision among the nitrogen molecules and the hydrogen molecules will increase. So when they collide in the correct orientation, if successful collisions occur, then we can produce more yields. But again there is a problem. If you increase the pressure, now we will typically use 2 atm, or 2 atm means 200 Pascal, 200 kilopascal, right? So 200 kilopascal. You can mention what are the units that we use for measuring the pressure. Atm we can use, kilopascal or Pascal we can use, and we can use millimeter Hg also, right? Now what is the relationship between this atm and Pascal? Because in the examination they might ask these typical conditions in atm or Pascal. So if they don't specify the units, you can give in the unit you prefer, but if they ask, you have to give in that particular unit. Now 2 atm, what is 1 atm? 1 atm is equal to, in Pascal,
1.3 kilopascals.
1 into 10 power 5 or 1 power 3 Pascal, right? So now you can say 2 atm or 2 into 10 power 5 Pascal or 100 kilopascal, right? So that is just a mathematical conversion. Now if you increase the pressure. Now typically this is higher than the atmospheric pressure. Atmospheric pressure is 1 atm, but we are applying 2 atm, means we are literally increasing the pressure. Now if you increase the pressure to this system, what will happen?
If you what? Sorry, if you increase the pressure,
Yeah.
will go to the reaction will favor the side with the less number of moles, so it will favor the forward reaction.
It will favor the forward reaction. So
Oh.
now you see here, if you increase the pressure, definitely you can increase the
Yield.
yield. But we now you see we are using only 2 atm, but they are not using 5 atm. Why? If you use 5 atm, definitely you can produce more ammonia.
Because economically that isn't viable.
Economically that is not viable because
unsafe.
yes, definitely, right.
Because it's explosive, right?
Cost, yeah. Now, raw materials required to produce ammonia, what are they? Nitrogen gas and hydrogen gas, right? Now, yeah, fractional distillation, how we can obtain these raw materials is given here, right? Liquefied, as I explained you, we have to first liquefy the atmospheric air, and then from that we have to separate this nitrogen gas. And hydrogen gas is obtained by cracking hydrocarbons, naphtha or methane. Even you can use methane, right? So if you crack, means if you break it. Now if you crack carbon, methane, what can you produce? You can produce carbon and hydrogen gas, right? So we are not going to use carbon for this product, but we will use this hydrogen gas for our production of ammonia. Okay, and
Okay.
that's all. Right now, these are not important. Right now here, this is how we are going to produce ammonia by H2 and N2, right? So here, yeah. So here 450 to 500 degrees Celsius. You should remember these things, right? You should remember these things. And the pressure is, 2 atm is for only that sulfuric acid production, right? Now here 250 to 300 atm is the typical pressure, right? And one more method that we can do to enhance the yield is to add catalyst to the reaction system, right? Now for this reaction, the catalysts are iron or iron oxide and K2O or Al2O3. Industrially we can use these catalysts, right? So we already know that 3D transition elements can act as good catalysts, right? So here in that sense, iron is the perfect catalyst, and in addition to that you can use K2O and Al2O3 also, potassium oxide and aluminium oxide as catalytic promoters, which means it will enhance the speed of the reaction. But you have to bear in mind that this usage of catalytic promoters will not enhance or will not increase the amount of yield. It will not.
Yeah, it just speeds it.
It will just speed the reaction. Okay. There are some description. I will just share this file to you. You can just go through during your.
I was going to take notes as well.
Okay. And I talked to your mom. After finishing your sessions, if you can scan your notes and send me, then if you have any doubts, I can explain later. Right. So after finishing, okay. Right. Right. Now the next thing is, why do we need to use ammonia? The usage or advantages of ammonia. Now for production of nitric acid, definitely that is what we are going to study under Ostwald process, right? So now during the Ostwald process, now the ammonia can be used as a raw material. So ammonia doesn't exist naturally, we have to produce it industrially, right? So we will get ammonia from the Haber process, and it will be again used for the production of fertilizer. In addition to that, it will be used for the production of nitric acid also. And fertilizer is the main usage, right? So whenever you hear the word ammonia, this fertilizer should come into your mind, right? So that is the main usage, right? And we can use this for nylon also, right? and petroleum industry. Now these are just usage of ammonia, right? So used in refrigerant. So these are just usages, but the main usage is fertilizer and nitric acid, right? So if you remember these 2 points, that is enough, and for your reference you can just read these things. Now we will move to this production of nitric acid. Okay, so nitric acid, HNO3, this is an acid. Now for this, ammonia gas and atmospheric air and water are used as raw materials. Raw materials are the substances from which we are going to produce the useful chemicals, right? Now nitrogen dioxide gas obtained by the reaction between ammonia and oxygen gas is reacted with water to produce nitric acid. Now here we have 5 reactions. You should know all these reactions. Now starting from the raw materials, we are going to produce this HNO3 ultimately. Okay, now ammonia gas, it is obtained from Haber-Bosch process, and we just burn this ammonia to produce NO gas and H2O gas, right? So now this is an exothermic reaction, because during this process this amount of energy is released, but you don't want to actually remember this value. You should just know this is an exothermic reaction. Why? Because typically burning reactions are exothermic, right? And again this produced NO gas is again burnt. Why? Because this is a kind of incomplete burn, incomplete combustion, right? Now if you again burn it, it will produce NO2 gas. Now now we wanted to study about this catalytic reduction, right? So why do we use catalytic reduction? Now for example, the catalytic converter in the exhaust of the vehicles, we produce NO gas, NOx gas. Now NOx gas is a harmful gas. This is harmful, right? So this is not environmentally friendly. So we have to reduce it into N2 gas and oxygen gas. For that, in the exhaust of the vehicles, we use this catalyst, right? So typically platinum, palladium and rhodium, RH, right? So we have now this is a kind of setup like this. Let's say from the engine the gases, NOx gas comes, and here we have some layers, right? So these layers are perforated. Perforated means what do you call this? Porous. No, porous, perforated.
Yeah.
Perforated mean having holes, right? So this NOx gas, now these layers are made up of these metals, platinum, palladium and rhodium, right? So these are actually expensive metals, but we are using in order to reduce it, right? So NOx should be reduced to N2 gas and O2 gas, because N2 gas and O2 gas are not harmful, but NOx gas is harmful. It can produce photoelectric smoke, photochemical smoke, right? So this is an adverse environmental effect, right? And now for example, if you take carbon monoxide is also harmful. It can also produce photochemical smoke, and it can contribute to this acid rain also, right? Now it can be reduced to carbon. Hello? நான் லேட்டாக தான் போவேன். 9 மணி போனால் போவேன். வாரண்டைக்கு ಇದೊಂದು ರೀ ಕಾಂಪಿಟೇಷನ್ ಉಂಟು, ಲೇಟ್ ಆகும், ஒரு 8 மணி ஆகும் இரவிக்கு. ஓ வாரன் கிளாஸில் இருக்கேன். Yeah, can you just give me 5 minutes? I will just drop my sisters to school and come.
Yeah, okay.
Okay, I'm sorry for that disruption. Okay, shall we continue? Are you there in the meeting?
Yeah.
Okay. So I was telling that in the catalytic converter, we use perforated layers made up of this platinum, palladium, and rhodium, right? So these are actually expensive metals, but we will at least use around like 1 to 4 grams of these metals to produce these layers, right? So what it will do is it will just finally reduce this NOx to N2 gas and O2 gas. Now these are not environmentally harm, right? Okay. And in addition to that, if you produce carbon monoxide, if you produce carbon monoxide by the vehicle or automobile engines, now again we have to reduce it to carbon dioxide. Now carbon dioxide is not a useful gas, which means useful in the sense it is also harmful, but comparatively compared to carbon monoxide, this is less harmful. Carbon dioxide, right? But still it is also responsible for global warming. This is a greenhouse effect, greenhouse gas. The greenhouse gas means it can contribute to the increase in the global temperature, right?
Yeah.
But it can be utilized by the plants for photosynthesis, but carbon monoxide cannot be used for photosynthesis, right? So that's why we have to reduce it to carbon dioxide, so that it can be even used by the plants to produce energy for their consumption, right? Okay. Now NO gas, again O2 gas, it is made reacted with O2 gas to produce NO2 gas. Now again this NO2 gas should be dissolved in water to produce HNO3 aqueous, right? And again when NO2 gas dissolves in water, again NO gas is produced. So what you should do, you should reduce this NO2 gas. Now again this NO gas, now you can do two things, right? So the first one is we shouldn't let this NO gas to the environment, right? Why? Because this is harmful. So you should subject this NO gas to the catalytic converter to N2 gas and O2 gas. But if you think creatively how you can recycle this NO gas, now again if you burn this, again NO2 gas can be produced, right?
Yeah.
Now after producing this NO2 gas, you can again utilize this for producing more HNO3. Why? Because we have to produce more HNO3. Now you see here, if you use this NO gas to the catalytic converter, it can be only made to N2 gas and O2 gas. So this is waste. But if you again dissolve this into, if you just oxidize to NO2 gas, and then again NO2 gas can be dissolved into water to produce HNO3 gas. So you should remember all these five reactions. Okay. So this is just a simple illustration for this process, right? So we use this NH3 gas and O2 gas as raw materials. Now the reaction happening is, what is the reaction? NH3 gas plus O2 gas will produce NO gas and H2O gas, right? Now here we have to use platinum as catalyst here in this chamber, right? So NO gas comes, right? So through this NO gas comes, and what are the NO gas and H2O liquid? So only NO gas is coming. Now again NO gas should be mixed with oxygen gas. That's what happens here, right? So again in this second chamber, NO gas is mixed with oxygen gas to produce NO2 gas. Now again this NO2 gas should be dissolved it into water to produce nitric acid. So finally we have nitric acid. Okay, so here finally we will obtain nitric acid through
Okay.
this tube. Yeah, I'm sorry, am I audible?
Yeah.
Okay, now NO2 gas comes through this tube, right? So here water will be sprayed, right? So here this is kind of an a setup to spray the water. Okay, so now you can see here from this top we can spray the water so that it can mix with the NO2 gas and ultimately we can produce nitric acid, right? So this is absorption chamber, means the water absorbs NO2 gas to produce nitric acid. That's why we call this as absorption chamber. And again you see what are the waste gases that we produce here?
Nitric acid. Wait, no.
No. You see here, NO gas is a waste gas, right? So again, during this process, NO gas is a waste gas. So NO gas will come through this tube. Again, this will be again utilized in another setup to produce this NO2 gas. And again, from that, okay, now you see here, NO gas comes here, right? So through this NO gas comes. So this NO gas will be again, now we have to extend this, right? So industrially we have to extend this. Let me just draw that picture here, right? So we will just extrapolate this tube and here we will have another chamber. Now here you can insert oxygen gas and ultimately again it will produce NO2 gas, right? So again this NO2 gas will be again now the same thing, right? So again NO2 gas, now we can connect this here, right? So if you connect this here, again the NO2 will come here again and again. So this is a cyclic process, right? So this, the coming NO is again converted to NO2 gas and inserted here, inserted into this oxidizing chamber. So now you see the names here. This chamber is called oxidizing chamber and this is called absorption chamber, right? Now here we have two chambers. Sometimes they might ask to write down the names of the chambers and the reaction happening in each chamber. Now in oxidizing chamber what happens? NO gas is oxidized to NO2 gas, and in absorption chamber the NO2 gas is dissolved in water. The NO2 gas is dissolved in water. Okay,
So,
right. Now this is the idea how we manufacture this NO2 gas. I'm sorry, HNO3 nitric acid. Okay, now the description is given, you can just read it, and the uses, right? So you don't need to deeply read this, but you should know all these reactions, and you should be able to roughly sketch this illustration and label them. Okay, so you can just try to draw it yourself, and you have to remember the equations and the chemical reaction happening in each chamber, right? Now here, how can now earlier, if you look at the previous question that we that I just explained in the video, they are asking how we can increase the efficiency of this process, right? So now the oxygen gas was recycled, yeah, in the production of ammonia, right? So likewise here, NO gas is recycled without converting it into N2 gas and O2 gas, because we cannot let the NO gas into the atmosphere because it is harmful. So we can do two things. We can use catalytic converter to make it N2 gas and O2 gas, but it's waste. Again, how can we increase the efficiency of this? Now, similarly, they asked to suggest a method to increase the efficiency of this production procedure. So here, what is the method that we adhere to increase the efficiency? NO gas is recycled to produce HNO3 gas again, right, sir? So here HNO3 gas is produced in two different scenarios, right? By directly and from the byproduct. This is a byproduct we can call, right? So byproduct is again oxidized to NO2 gas, and then again the NO2 gas is subjected to the oxidizing chamber, and again it is dissolved in water, right? So you should know all these 5 reactions, right? Right, so this is how you have to remember, right? So first you should remember the raw materials. So the raw materials are ammonia, air and water. We use all these things for our production process. So ammonia gas is oxidized to produce NO gas and H2O liquid. Again, NO gas is oxidized, right? So for the oxidizing purpose, we use oxygen. So this is also an raw material. Again, NO2 gas is dissolved in water. So that's why we call this H2O as raw material. Again, this is a byproduct. This NO gas is a byproduct. Can you understand that?
Yeah.
This is a byproduct. And again, the byproduct is recycled by oxidizing with oxygen, and NO2 gas is obtained. And then again, NO2 gas. If you get NO2 gas, again, it can be dissolved in water to produce HNO3, right? So you should remember all these things. Now, right, here, these are the usages, right? So usages, fertilizer and explosives, right? So especially nitric acid can be used to manufacture explosives, right? And making nitrates, right? So from HNO3 we can produce nitrate, right? For example, if you add potassium, if you now you see K plus HNO3, right? So what will it produce? H2 gas and KNO3, right? So similarly, if you react silver with HNO3, it will produce H2 gas and AgNO3. So here this KNO3 and AgNO3 are the nitrates essential for industries. So these are the nitrates that are used in the production of some other useful things, right? So KNO3 is used to produce gunpowder, and AgNO3 is produced for photography. It is used in photography inks, right? So it is used for the production of photographic inks. So you should remember these usages also, right? So nitric acid. So after what they will ask is, now here they will just give this as this one, right? So here if they give this as an equilibrium reaction, they will ask how it relating to Le principle. They will ask some questions, right? So what will happen if you increase the pressure, what will happen if you increase the temperature, and so on. After that, they might ask a question to write down the usage of this nitric acid. So you should write down all these things, right? So you should remember, right? Fertilizer, that is obvious, and explosives, KNO3, AgNO3 are used to produce gunpowder and photography respectively. then making aqua regia, and cleaning surfaces when welding metal. So these are just usages, right?
Okay.
Now we will move to the third one, that is contact process H2SO4, right? So do we have any questions relating to this contact, what do you call this, Ostwald process in the past paper? Did you see any questions?
No. It's just mostly memorizing, isn't it?
Yeah, there is nothing to explain here. You just want to, first you have to understand the process, right? So you have to understand the process, but you have to memorize these chemical equations and then the usages. Okay, now moving to the contact process. Right, here contact process, the raw materials used for the contact process is sulfur, water, only sulfur and water and oxygen, right? Now we have to produce H2SO4, right? So sulfur, now in the earth crust we have some minerals which contain sulfur, right? So now we should extract this sulfur. Now we may have some ores, right? So what are ores and minerals?
Just just quickly, this isn't going to be in my test, by the way. The contact process.
Yeah,
It won't, because
yeah, because
unless it will be just general equilibrium, but this specific process won't be in it.
yeah, now you see here you can see an equilibrium reaction, right? So using this chemical reaction, they might ask some questions, right? So now you see here you have to apply 450 degrees Celsius. Now you will not exceed this temperature more than 450 degrees Celsius. Why? Because if you increase it, then the amount of SO3 will reduce. But we have to anyhow apply this 450 degrees Celsius because we have to overcome the activation energy, right? And here we will use just atmospheric pressure, right? So now just to give an idea, now you see here we will just count the number of right? So here we have 3, here we have 2. So if you increase the pressure, definitely the yields will increase, but maintaining the pressure will be high cost, right? Will be will cost more, so we will not use that. And you should remember these catalysts, right? So as I told you, in the production of ammonia we use iron, K2O and Al2O3 as catalysts, right? So you should specifically remember these catalysts. Now here they cannot ask any questions related to this equilibrium because none of the equations are at equilibrium, right? You can see all are complete arrow marks. But if they want to ask any question, they might just ask you to consider this as an equilibrium and then ask questions. But here there is no way to ask any equilibrium related questions in the production of nitric acid. But in NH3 they can ask. Why? Because the equation involved in the production of ammonia is an equilibrium reaction. N2 plus H2 gives NH3. But here you cannot observe any equilibrium reaction. But here in the production of sulfuric acid using contact process, the second step reaction is an equilibrium reaction. So they might ask questions, right? So just to give an idea, right, now you see here, right? So this is just a question, right? We will just try to answer this one to have an idea about the sulfuric acid, how they can ask questions, right?
Yeah.
Right. So if you just look at this one, right. So here in the third question, they have asked a question related to the ammonia production, but they cannot ask any equilibrium related question in the process of Ostwald process, right? So they can ask only the industrial related question, right? Because there is no equilibrium reaction, right? So here,
isn't the two first ones equilibrium?
I'm sorry,
When you oxidize ammonia and aren't all three of them equilibrium? I learned that all three of them are equilibrium.
which one?
When you oxidize ammonia, when you oxidize thing,
In the Ostwald
nitric
process?
oxide,
Yeah,
every step in it is equilibrium,
yeah,
right?
yeah.
Yeah. On this one, I think it said that the last one, when we isn't equilibrium, but
Right. So here, yeah, some reactions are at equilibrium, right? Depending on the condition, right? So if you see any aroma like this, they can ask questions, right? So now we will just see how they can ask questions in Haber process ammonia, right? So the symbol equation for this industrial production of ammonia is shown, right? So they will just give the equation. Now this is an exothermic reaction. Name of this industrial process. What is that? Haber process. Now state the meaning of delta H. That is also okay. Now after that, now they will ask you to write down the typical conditions that we use, right? So typical conditions. Now what is the temperature? 450 degrees Celsius to 500 degrees Celsius, right? And what is the pressure?
200
200
to
atm.
300. Yeah.
Okay, right. And what is the catalyst we use here? Fe or K2O or Al2O3. These are the catalysts that we use, right? Now in D part they are asking, in D part, state two methods of increasing the rate of reaction. So what are the methods that we can use to increase the rate of reaction? To increase the rate of reaction, what methods can we follow?
They could utilize a catalyst
Yeah, utilizing catalyst,
and increase pressure.
increasing pressure, increasing temperature, right? So you should be able to explain also, right? So if you utilize the catalyst,
Talk about the Vesper theory.
it will reduce activation energy and enhance the rate of reaction. And if you increase the temperature, what will happen? According to collision theory, kinetic energy will increase, and then collisions will occur, more collisions will occur, and then rate of reaction will increase, right?
Reaction.
Okay. Now here, right, here H2SO4, right? So this question is about sulfur and compounds of sulfur, right? So sulfur is converted into sulfuric acid, H2SO4, by the contact process. Now the process involves 4 stages, right? So 4 stages, yeah. Now you can see, right? It involves four stages. First one, second one, third one, and fourth one. So now we should understand what is happening in the production of sulfuric acid, right? So we should know what is ore and what is mineral. Can you define the terms ores and minerals?
Ores are rocks that are impure with the metals.
Metals. And minerals?
I'm not sure about minerals.
Minerals are naturally existing organic substances, right? Naturally existing organic substances. Now, all ores are minerals, but not all minerals are ores. Now, ores are the minerals. Ores are also minerals, but from which we can extract metal from, right? We can extract metal from, for example, hematite and other stuffs, right? So here, when extracting the metals Pb, now you see we have some ores from which we can extract Pb, copper and zinc. Now in addition to this Pb sulfide, copper sulfide and zinc sulfide, now these are contaminated with sulfides, right? So when you extract these metals, sulfide can be a byproduct, right? So for example, let's say you have to extract Pb and copper and zinc from their respective ores, right? From their respective ores, but they are contaminated with sulfide, right? So after extracting this Pb sulfide, again you have to split it into Pb and sulfide. Now here the sulfur is a byproduct in the production or in the extraction of this Pb, copper and zinc, right? So we should have some mineral ores, right, from which we have to extract Pb, copper and zinc, but they are contaminated with sulfide, right? So during this process, what is a byproduct? Sulfur is a byproduct. So sulfur is a byproduct. Byproduct is what? Byproduct are the unwanted substances that we obtain during a main process, right? So now during the process of extracting these metals, sulfur is a byproduct. Now this byproduct can be utilized for the production of sulfuric acid. Okay, and again in the earth crust also we have some minerals we can directly extract from them. And during the petroleum refining also sulfur is a byproduct, right? So the byproduct is used here. Now the sulfur should be oxidized using oxygen to produce SO2 gas, and again this SO2 gas is reacted with oxygen gas to produce SO3 gas. This is an equilibrium reaction. So based on this reaction, they will ask question, what will happen? So here nothing, Le-Chatelier principle and these two equations. Delta G is equal to delta H minus T into delta S. So now how can you use this equation? Now during this reaction, now you see here, what will happen to delta S when this reaction happens?
Sorry?
What will happen
According
to
to
entropy change?
So because there's 3 on the left and then 2 on the right, entropy decreases.
So if entropy
negative.
decreases, what will happen? Now delta H is negative, right? So now
And then negative, and then
delta H is
the
negative, and
right hand side is also negative, so it will overall be positive. Delta G will be positive.
positive. So if delta G is positive, what will happen? The reaction will not be spontaneous, right?
Non-spontaneous,
But so here increasing the temperature, if you increase the temperature, the delta G will become positive. So increasing the temperature is not thermodynamically favorable for this reaction. But why we use this 450 degrees Celsius is to overcome the activation energy. If you reduce the temperature below 450, the efficiency of the reaction will reduce. Why? Because we will not produce more SO3. And increasing also not possible. Why? Because according to Le-Chatelier principle and this equation, it will again produce more less amount of SO3 gas. So this temperature is called optimum temperature. Right? And increasing ATM with respect to pressure, you have to tell that is not economically favorable. It will cost more. And during this process, V2O5 is used as a catalyst. Now SO3 gas is again used with H2SO4. Now you see here, for the production of sulfuric acid, we require some amount of H2SO4 initially. If you want to produce large amount of sulfuric acid, we need little amount of H2SO4 as a raw material, right? So SO3 is again used with H2SO4 to produce this substance. This is called oleum. What is this? The name is oleum, H2S2O7. Again, this oleum is dissolved in water to produce H2SO4. Okay. Now here you can just see this picture. Now here dry air means oxygen gas is produced, and liquid sulfur, right? So from the byproduct of petroleum refining and extraction of metals from their ores, we have sulfur, and it should be liquefied, and the liquid sulfur comes here. So liquid sulfur, now the reaction happening in this chamber, burning sulfur, burning of sulfur means this one, right? So sulfur plus O2 becomes SO2. Now SO2 gas comes through this, and it is again mixed with oxygen gas, right? So here SO3 gas will come, right? So SO3 gas will come, but this reaction is happening here, right? So you can see here, this is catalyst, this is catalyst, right? So what are catalysts? V2O5. This layer is made up of V2O5, and the equilibrium reaction of S plus SO2, SO2 plus O2, right? SO2 plus O2 gives SO3, happens in this chamber, right? Now SO3 comes here. Now you see, in the previous method of producing HNO3, from the above we sprayed water to mix it with NO2 gas, right? So we discuss here, right? Here NO2 gas is coming, and we sprayed water, but here we are spraying H2SO4, little amount of H2SO4 to produce H2SO, this oleum, H2S2O7, reacting with SO3 gas. Again, now here this is oleum, right? So this oleum is coming through this tube, and we have to incorporate water to this tube, so that ultimately we can get H2SO4. This is how industrially this sulfuric acid is produced. So you should remember that for the production of sulfuric acid, we need sulfuric acid. Okay, we need little amount of sulfuric acid. Now we will move to this question. Here they have asked a question, right? So this question is about sulfur and compounds of sulfur, right? So they have given all these stages, and now they are asking, so the equation for stage 2 is shown. So based on that equation only they will ask questions, right? So the forward reaction is exothermic. They will provide this reaction is exothermic. Otherwise you should know, since this is a synthesis reaction, it will be an exothermic reaction. Okay, so explain why a temperature greater than 450 degrees Celsius is not used. Why? You can argue based on two concepts. First one is Le Chatelier principle, and the second one is delta H is equal to, and that equation, delta G is equal to delta H minus T into delta S, right? So what will happen when you increase the temperature? The delta G becomes positive, so the chemical reaction will be thermodynamically unfavorable. Okay, right?
Okay.
Now can you just try to answer this one? Explain why a temperature, I don't want to write down the answer, right? So you can understand. You can write, no? According to Le Chatelier principle, what can you tell? Since this is an exothermic reaction, increasing the temperature will shift the equilibrium backward. And now they might ask this question also, why we need to use 450 degrees Celsius as optimum temperature? Why can't we reduce it?
A lower one will, if we lower the temperature, there won't be the reaction won't be able to overcome the activation energy for the forward reaction to occur.
Right.
And if we temperature higher than 450 degrees Celsius, it will favor the backward reaction, decreasing the yield of SO3.
Yes, very good. Now explain why a pressure lower than 2 atm is not used, right? Now if you lower the temperature, what will happen? If you lower the pressure, what will happen? It will shift to backward. Why? Because here we have 3 and here 2. If you reduce the pressure, the equilibrium will shift to the direction in which we have more number of moles. Why? Because the system will tend to increase the pressure by adding more moles, right? So
Yeah.
if you lower the pressure than 2 atm, what will happen? Again, the production of the yield will reduce, right? That's why
Will
we
reduce
don't reduce the temperature than 2 atm, right? So for each and every process, you have to check in which side you have more number of moles, and according to that you have to write down the answer, right? So for this, how can you write down the answer? If you reduce the temperature, the efficiency of the production will reduce. Okay,
Yeah.
right. And here, these are some general questions, right? Can you just take the screenshot of this and try to answer later?
Give me 1 second.
Yeah, this
Uh,
one.
okay. So yeah, okay, got it.
Okay. And
So
here,
write the sulfuric acid H2SO4 plus.
yeah, so
Okay, yeah.
you don't want to study about this contact process?
I don't think it's necessary for this
Yeah, for this,
exam.
but anyhow we have to study, right? Because this is
Yeah,
a
because
very
like
important.
it'll be in module 8, but there's still a while until we go
Yeah,
to module
so
8.
in this one, okay, because this Leach-Atelier principle is useful in predicting the industrial condition in the manufacturing of chemical products, right? So here they will
Yeah.
ask, sometimes they might ask question, right? So they will not ask any question related to the industrial questions about this manufacturing of H2SO4, but they will directly give the equation, and from that they can ask questions, right? For that we have already practiced a lot. What will happen when you increase the pressure, and also, right? So here you should have the idea about this Ostwald process, right? So I have cleanly explained this Ostwald process in NH3 Haber process, right? And catalytic reduction also, you should know why we need to perform this catalytic reduction. We shouldn't let the harmful gases to the environment. That's why we reduce this, right? We reduce this, right? Now I have to stop now. Okay, so now what you have to do is, when you have exam,
Inshallah tomorrow morning.
tomorrow morning. So can you bring the paper, the final, the question paper, or do you write down the answers in the paper itself and submit to the invigilator?
We will write it down in the paper and then they'll mark it, and
You
yeah,
will bring the question
and
paper home.
no, we aren't allowed to bring the question paper home. So what will happen is, inshallah, tomorrow my test is 8:30 to 10:30,
Uh-huh.
and then right after my exam's done, I'll just come home. We can't bring the exam paper back,
Okay.
and then the teachers and all will mark it together,
Mm-hmm.
and then I don't know when we'll get it back, because there's only 2 weeks left of this term, but hopefully we will get it back this term. So yeah.
Okay, so after finishing so only one examination you will have for your this term, and after
Yeah.
that we can so after finishing your exam we can hopefully start the titration and continue our theoretical parts, right?
Yes.
Okay. So all the best for your exam. Do well, and we will meet in the next class.
Thank you.
Okay.